On June 8, 1918, the moon's shadow crossed the United States from Washington State to Florida in 47 minutes. It was the last coast-to-coast total eclipse this country would see for 99 years. That shadow is coming back. Not one like it, that one. On the evening of August 22, 2044, it will come down out of the Canadian Arctic and stop over Great Falls, Montana for about 90 seconds, with the sun almost touching the horizon. Astronomers have known that date for more than a century. They know the width of the path, the second it begins, and how far the sun will sit above the horizon when it does. 15 degrees, low, almost sunset. Because eclipses are not events, they are members. Every total eclipse belongs to a numbered family that runs for roughly 1,200 years, produces about 70 eclipses, and then dies. 1918 was member 42 of a family called Saros 126. 2044 is member 49. And member 49 is the last total eclipse that family will ever produce. After Montana, its shadow misses the Earth entirely and never goes dark again. So America is not waiting 20 years for an eclipse. America is waiting for a death. 6,585.3. It is a count of days. 18 years, 11 days, and 8 hours. Wait exactly that long after any solar eclipse, and another one happens, and it is almost the same eclipse. To understand why, you need 3 numbers. First, for a solar eclipse, the moon has to be between us and the sun. New moon. From one new moon to the next is 29.53 days. Astronomers call it the synodic month. If that were the only requirement, there would be an eclipse every month, and obviously there is not. Second, the moon's orbit is tilted by about 5 degrees against the plane the Earth travels in. So most new moons, the moon passes above or below the sun from our point of view and throws its shadow into empty space. There are only 2 points where it crosses that plane. Those are the nodes. An eclipse needs a new moon at a node. Node back to node is 27.21 days, the draconic month. Third, the moon's orbit is an ellipse, so the moon is closer to us at some points than others. That decides how big it looks, which decides whether you get a total eclipse or a ring of fire. Closest approach back to closest approach is 27.55 days, the anomalistic month. 3 cycles, all running at once, all slightly out of step, none of them a neat multiple of the others. For a good eclipse, all 3 have to line up. New moon at a node with the moon close enough. That triple alignment should not repeat on any obvious schedule, except it does. 223 synodic months come to 6,585.32 days. 242 draconic months come to 6,585.36 days. 239 anomalistic months come to 6,585.54 days. 3 completely independent cycles of the moon's orbit with nothing to do with each other, all landing on the same total within a fifth of a day. That is the Saros. Babylonian astronomers spotted the 18-year rhythm in eclipse tables over 2,000 years ago, working with nothing but records and patience. They couldn't have told you why. They simply noticed eclipses rhymed and wrote down the interval. Which means every eclipse in history has a family and a number. The one that gave America 1918 is number 42 of 72 in Saros 126. That family began with a small partial eclipse near the South Pole in 1179. It ends near the North Pole in 2459. 1,280 years from first to last. Here is the part of that number nobody explains. 18 years, 11 days, and 8 hours. The 8 hours. If the interval were a whole number of days, the next eclipse in a family would arrive at the same time of day with the same face of the Earth turned toward the Sun. It would land in roughly the same part of the world every time. But it is 8 hours over, and in 8 hours, the Earth turns 1/3 of the way around the planet. So, when a family fires its next member, the geometry in space is nearly identical. Sun, Moon, and Node back where they were. But the planet underneath has rotated. The shadow comes down roughly 1/3 of the way further west, which is written down in a column in the catalog. Read it. 1990, greatest eclipse at 169 degrees east, Finland and the Soviet Arctic. 2008, 72 degrees east, Siberia and northern China. 2026, 25 degrees west, Greenland, Iceland, and northern Spain. 2044, 120 degrees west. Count the gaps. 97 degrees, 97 degrees, 95 degrees. The same step west every 18 years for 1,000 years. So America is not waiting for a new eclipse. America is waiting for its turn on the wheel. But the family is doing two things at once, and the second one is worse. While it walks west around the planet, it is also climbing north. Every member of Saros 126 arrives a fraction higher than the one before, because 18 years at 11 days is close to a perfect repeat, but it is not perfect, and the small error goes the same direction every time. Turning through longitude decides which country stands underneath. Rising through latitude decides whether there is anything to stand under at all. And here is what the climb has already cost. In 1990, this family put the Sun 40 degrees above the horizon at greatest eclipse. In 2008, 34. In 2026, 26. In 2044, over Montana, 15. And the totality is shrinking with it. 2 minutes 33 seconds, 2 minutes 27, 2 minutes and 18, 2 minutes and 4. Every member of this family is a slightly worse eclipse than the one before. Lower sun, shorter darkness, further north. It has been getting worse in the same direction at the same rate as long as anyone has kept records. But this family has not always been dying. Go back to that Saturday afternoon in 1918. The country took it seriously. The United States Naval Observatory sent an expedition to Baker City, Oregon, funded by a special grant from Congress. Astronomers traveled from across the country. The whole apparatus of American science pointed itself at one afternoon in eastern Oregon. And on the morning of the 8th, the clouds closed over. S.A. Mitchell, director of the Leander McCormick Observatory at the University of Virginia, was standing in Baker City. He wrote afterward that soon after 3 o'clock, the clouds became so black the whole sun was blotted out, and that the hearts of the assembled astronomers sank. By 3:45, the cloud had thinned enough to see the corona. Photography in 1918 could not capture what the eye could see. Film could record the shape of the corona or the brightness, not both. So the plates came back looking nothing like the thing people had stood outside for. Which is why the American Natural History Museum had hired a painter. Howard Russell Butler was an artist who had trained in physics. He had developed a shorthand system for recording color and structure at speed, and he used it that afternoon on the corona. He had 112 seconds to work with. The painting he made from those notes is still the best surviving record of what that eclipse looked like. All of it while the country was at war. Between casualty lists and troop movements, a few inches of column explaining that the sun would go out over Denver at tea time. Now look at what that family was capable of then, against what is left of it now. In 1918, the moon's shadow struck the planet almost square on. The sun set 62 degrees above the horizon at greatest eclipse, high and clean. The path was 66 miles wide on the Pacific coast and 40 by the time it reached the Atlantic. Narrow, because a shadow arriving straight on makes a small, tight footprint. Totality 2 minutes 23 seconds over Denver in the middle of the afternoon, in the middle of the country. 2044. The sun 15 degrees up, close to setting. A path 281 miles wide, which sounds better and is not, because that width is the signature of a shadow arriving at a slant and smearing across the curve of the Earth. Totality 2 minutes and 4 seconds at best, and only about 90 seconds by the time it reaches the American section of the path. Same family, same moon, 126 years apart. In 1918, it crossed 1,400 miles of American mainland at high afternoon. In 2044, it will clip the top edge of Montana and the Dakotas at sunset and be gone. This family is not returning to America. It is leaving, and it happens to pass over Montana on the way out.
So here is that Monday evening. The path begins over Greenland and runs southwest across Nunavut and the Northwest Territories down over Alberta and crosses into the United States late in the day. It passes over Great Falls, Montana, and Williston and Dickinson in North Dakota and clips a corner of South Dakota. One piece of housekeeping. The catalogs list this eclipse as August 23rd because astronomers work in universal time and greatest eclipse falls just after 1 in the morning UT. On the ground in Montana, it is the evening of Monday, August 22nd. If you're booking anything, book the 22nd. 15 degrees is about the width of your outstretched hand at arm's length held sideways, which means nobody in the United States will be looking up at this eclipse. They will be looking sideways, out across the plains, into the west. And that gives you something almost nobody has photographed. In a high sun eclipse, the corona appears in a sky gone black all the way around. A sunset eclipse does not do that. The corona will open against a sky that is blue above and burning at the bottom, with the silver of it sitting directly in the color. The shadow will arrive almost horizontally across the ground, not dropping on you from above like weather overhead, coming at you across the plain like weather. 90 seconds later, it comes back, and about half an hour after that, the sun sets properly. And then, 18 years and 11 days after that, the family returns one more time. September 3rd, 2062. 97% of the sun will disappear behind the moon. It will be the deepest eclipse Saros 126 has ever produced, and it will be a partial. Nobody, anywhere on Earth, will see totality. 97% covered, and the sun stays lit. Because the surface of the sun is roughly 1,000,000 times brighter than the corona around it, a sliver is enough to keep the sky blue. There is no gradient at the end of an eclipse. You get everything, or you get a bright afternoon with something odd in the light. The reason it fails is that by 2062, the shadow has finally climbed off the top of the planet. The dark core passes above the North Pole and touches nothing but space. There are 23 more eclipses in this family after Montana. 2062, 2080, 2098, and on every 18 years and 11 days, until the 3rd of May, 2459, when the last member shades 2% of the sun above the Arctic Ocean with nobody underneath. Every single one a partial. The same way it began, in 1179 at the other end of the world. 72 eclipses, 1,280 years, 10 of them total, across a window of 162 years that opened in 1882 and closes over the northern plains of the United States on a Monday evening in 2044. It opened on America. It closes on America. That's a coincidence. It's a very good one.
Great Falls has about 60,000 people in it. Almost none of them have ever had a reason to think about Saros 126. In 18 years, the sky above them will do something it will not do again, and the date has been sitting in a table waiting for longer than any of them have been alive. There is more to this than one family. There is the eclipse of August 12, 2026, which crosses the North Pole and touches no part of America, and which is the same eclipse as 2044, one turn of the wheel earlier. There is the reason the shadow misses. There is what the mirrors left on the moon by Apollo have measured about how long total eclipses have left at all. That is the full film, and it is linked below. But the number to keep is this one, August 22nd, 2044, Great Falls, Montana, 90 seconds. It is already on its way. It has been since 1179.